All right, gang, we are going to work through the free response from the first part of the 6 weeks exam. So hopefully you can see this at least well enough following along with yours to figure out what's going on. So we're talking about continuity here. It's telling us to keep in mind the conditions for which a function is continuous at x equals c. Those three conditions are that the function has to be defined at c, the limit as x approaches c of the function has to exist, and the limit and the function have to equal each other. So part A asks us to draw a graph of a function that satisfies the following conditions and then state if the function is continuous at 3 or not. And we have to give the reason based on the three-part definition for continuity. All right? So let's look first at drawing our function. Most of us did a really good job on this. So it tells us that h of 3 equals 4. So the function is definitely defined at 3 and it equals 4. But then the limit as x approaches 3 from the left and x approaches 3 from the right is negative 2. So the limit of the function, meaning that the function is headed towards negative 2 as we approach 3, but then it jumps up here. So definitely not continuous. So let's talk about why. We can't just say because there's a hole in a graph and it jumps up. We have to use our definition of continuity. So I'm going to first of all say that h of x is not continuous at x equals 3. Here's why. And I'm going to go ahead and state the first two conditions are true. While h of 3 is defined, and the limit as x approaches 3 of h of x exists, the limit as x approaches 3 of h of x is equal to negative 2, which is not equal to 4, which is h of 3, which is just kind of a long way of saying that these two things aren't equal to each other. The limit equals negative 2, the function equals 4, so they're not equal to each other. Okay, so therefore h of x is not continuous. All right, it would have been fine if you had just said that h of x is not continuous at x equals 3 because the limit as x approaches 3 of h of x equals negative 2 and h of 3 equals 4, and those are not equal to each other. That's totally fine. All right, let's look at part B. Part B, I'm going to shift the camera a little bit. Okay. Part B gives us a new function, a piecewise defined function. That's actually, the two pieces are continuous functions and they meet up or hopefully meet up at 7 if it's going to be continuous. It asks if f of x is continuous at x equals 7 and to justify our reasoning based on the three-part definition of continuity. So let's start with part 1. Part 1 is f of 7 defined? Okay, well, let's see. Actually, yes. F of x is defined as 3 plus the square root of 2 plus x for all values of x less than or equal to 7. So it actually is defined at 7, and we are going to show what it equals at 7, which is 6. So yay, f of x is defined. Perfect. Question 2, we've got to check to see if the limit of f of x exists as x approaches 7. All right, so this is a piecewise defined function, and it's meeting up at 7. So we actually have to make sure that the limit as x approaches 7 from the left is equal to the limit as x approaches 7 from the right. And we're going to show our limit notation, and this actually makes it nice for us because once we have written this limit notation, we now are just going to do direct substitution. So to evaluate the limit of f of x as x approaches 7 from the left, then we need to use what f of x is defined for to the left of 7, which is actually this top function, all the values less than 7. So we're going to use direct substitution. Now, Ms. Eccles, you just did that up here to evaluate f of 7. I know, but you need to show it twice because this was for evaluating f of 7, and this is for evaluating the limit as x approaches 7. So then it ends up being 6. All right, over here on the right, we're going to use the second function because that's how f of x is defined, approaching 7 from the right. So we have 8 minus the square root of 7 minus 3. all right, which also gives us 6. 8 minus the square root of 4, 8 minus 2, which is 6. Fabulous. So the left limit equals the right limit, which tells us that the limit as x approaches 7 of f of x exists. Okay? The third part of the three-part definition of continuity is that the limit as x approaches 7 has to equal f of 7, which it does. They both equal 6. Okay? So, since all three conditions are met, we can say that f of x is continuous at x equals 7. Okay? This part was worth 2 points. This part was worth 3 points. All right? And then the last part is going to be worth 4 points.